All right, so if we're going to run correlation, there's a couple of things that we need to have happen. One, of course, we need an independence between our observations. So technically, we should have taken a simple random sample. As I keep saying in all these videos, if you did a convenient sample, there's probably some dependence going on. If you talk to particular classes or you talk to groups of friends, there's a reason those people might be similar. Now, if you don't have any reason to believe that they might be similar for your variables, it's fine. And even if they might be similar for variables, like in terms of hours of sleep, maybe my friends are like me. I am old, so most of us get a lot of sleep. Or have children, and then we get a little sleep, so who knows. But then I might say, okay, I'm technically not sure we have independence, but I'm going to proceed anyways because we've got to do the project. The next thing I need is technically I should have seen a linear trend in my scatter plot, and that's something I could just go back to my scatter plot and say, ish. I'm pretty sure that StatCrunch does a Pearson correlation, doesn't tell us, but technically our data should be continuous and not discrete. So here we have discrete data, which is problematic. But the thing I want the most out of all of this is that our data should be fairly normally distributed without any outliers. And that's for each of our two variables. So of course you could look at a histogram, like hours of sleep, cups of coffee, and you can say, oh, yep, that looks fairly normal, no real outliers, ish. That's getting a little sketchier because we have a more right-skewed distribution. But histograms still have a lot of subjectivity and are a little bit harder to necessarily read that way, though I'd say we're pretty good for both of these. But a different way to look at and see if we've got normality is to use a QQ plot. This is our normal probability plot. So I can grab both of these and just run a QQ plot. Since they're discrete, we're getting these weird little lines, but everything should be close to this red line, which it looks like, so we're pretty good there. This also looks fine. We're starting to see a little more problems with the cups of coffee, especially with the zeros, a little more violation of this normality idea, which of course is going to be violated because we're dealing with discrete. But that's where this right skew is sort of coming into play, and we're sort of seeing it. Again, this is very subjective, and you guys have not spent a lot of time reading QQ plots in your lives, if at all any. So unless this is completely crazy, let me see if I can find a QQ plot example. That would be bananas. Yeah, unless your QQ plot looks like this or this, you're probably fine, right? A little tailing off at the ends is fine. With discrete data, it's very hard to really say. But you can see all these like heavy-tailed and left-skewed, what happens with these different QQ plots and how far off the line your observations would be. So again, this doesn't look that terrible when you're looking at the other stuff. And we're really hoping to have all of these assumptions met so that our tests are legitimate.